This is OCR Higher, November 2017. Okay, and it's paper 5, which is a non-calculated paper. I've already done this first page, so I'll just talk about it, but it's only the first page that I've done. So the first one, write down the mathematical name of the line A. And the diagram shows a circle with centre O. So that's a tangent, when the line just touches the circle without cutting through it. And then the shaded segment, the shaded region B is called a segment. Don't mix it with a sector, which is like a traditional slice of cake. Segment across that way, sector, like that. Next term for each sequence. So this one is 1, 1, 2, 3, 5, 8. What you get is the sum of the two. The next term is the sum of the previous two terms. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. 5 plus 8 is therefore 13. Okay, so it's like we add those two together and we get that. We add those two together and we get that. 3. 1 plus 2 is 3. Okay, this one, when you observe it, as you go from term to term, the next term is the previous term doubled. So it's 64 times 2, which is 128. And the nth term here, okay, that was the sequence. They're going down in threes, so that's minus 3n. And then to find out, if we go back one, that would have been 18. So we add 18 on. Okay, number 3. Andrew's thinking of a number between 1 and 150. 1 more than a square number. 3 less than a cube number. It's not a prime number. Right, I'm going to start with these here, because this is the smallest category. Because we've got 150 numbers in there. We've got 12 in there. And there's lots of numbers that are not prime between 1 and 150. So I'm going to start with the cube numbers. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is more than 150. Okay, so we're dealing with this clue now, and it's 3 less, so the possibilities, it's, it could be, the number could be minus 2, 5, 24, 61, 1, 2, 2. Okay, we go here, it's between 1 and 150, means it's not minus 2, because it's got to be at least 1. Okay, now the next thing to do, it is not a prime number, because I've got these numbers here. 5, so it's not 5, 5 is prime, so it's not 5, and 61 is prime, so it's not 61. Okay, it's not 2, because it has to be between 1 and 150, so it's not 2. So it's either 24 or 122. 1 more than a square number. 24 is 1 more than 23, and that is not square, so it's not 24. 122 is 1 more than 121, which is 11 squared, so it's that one, it's 122. Okay, factorise. This is the difference of 2 squares. When you've got this is x plus 43 times x minus 43. So it's something squared, and it has to be a minus there, something squared there. So it's the square root of the first term goes first in each bracket, then you get a plus and a minus, then the square root of the second term goes there like that. Okay, so this one, I'll write it there. Okay, so here, 9. Here we've got a 57 for the x. We've still got 43. So that is 100 times 14. 54. Yep. So it's 1400. Okay, here's a coordinate grid. Draw the image of triangle A after reflection in the line y equals -1. So y equals -1 is this line here. And reflect A in there. So it's 2 away from the reflection line. So the image is going to be 2 away from the reflection line here. At that base of that triangle anyway. This here, well, this side is 3, so it's going to be 3 down there. And then that's there. We label that A dash usually. Describe fully the single transformation that maps A onto B. Okay, so this is going to be it's going to be, well, it's an enlargement, even though it's reduced. It's this one in the middle is gone a bit off. Oh, it's all going too well. It's technology. Okay, so you match up corresponding points like so. Okay, and it's going to be there. Okay, so to get from A onto B, it's going to be an enlargement. And the centre is where the 3 lines cross here, which is 5 across and 7 up. And the scale factor, the fact that it's reduced comes up with a fractional scale factor. Now, its scale factor is, look, this is 1.5 this side, and that one's 3. This is 2, and this is 1. Okay, so it's actually going to be scale factor 1/2. Okay, next one, complete this statement. A rotation of 180 degrees about 0, has the same effect as an enlargement by scale factor something with centre of enlargement something. So I can draw one on here. Let's do, I'll do it with a different colour. Right, let's, so what does it say? A rotation and around 0, same effect as an enlargement. So if we rotate it around 0, it's going to end up around there, 180 degrees. Now this is the corresponding points. So that one corresponds to that one there. That one is that one there. And that one is that one there. Okay, because that's when you rotate 180 degrees. Okay, so basically the centre of enlargement is 0. Okay, and the scale factor is -1. I think that's something you can't really see that scale factor on that diagram, but that is the answer. Right, this rectangle has length 4x minus 5, width x plus 3. The perimeter of the rectangle is 46. Calculate the area. So perimeter, so we've got x plus 3 plus 4x minus 5, and all that times 2, because the perimeter is the distance all the way around the outside. So we've got 2 of those, and that makes 46. So therefore, 5x minus 2 times 2 is 46. So 5x minus 2 is 23. 5x is 25. So x is 5. Okay, quick check. 8, and that's 15. Because that's 20 minus 5 is 15. So it's 23 for those two, and 23 for those. 46 as required. So the area is going to be 5 plus 3 times 20 minus 5. So it's 8 times 15, which is 120 centimetres squared. Okay, Naomi is given a 10% pay decrease her new wage is £250 per week, £252 per week. What would her weekly wage have been if instead she'd have received a 10% pay increase? So 290% of her original wages is £252. Okay, so 0.9 times the original wage is 252. Okay, so I'm going to multiply both sides by 10. So 9 times the original wage is 2,520. Then divide by 9. So that's going to be 2, remainder 7, 9 into 72. So original wage is £280. You see, and then so 10% would be 28. 28 from 280 makes 252. If she'd have got a 10% increase, she'd have £280 plus 28 instead of taking away, which is £308. Okay, the angles in a triangle are in a ratio 1 to 2 to 3. Show the triangle is a right angled triangle. So the total parts from the ratio 1 plus 2 plus 3, which is 6. So 180 degrees in the triangle divided by 6 is 30 degrees. So 1 to 2 to 3 is now going to be 30 to 60 to 90 degrees. It's got a 90-degree angle, hence it's a right angle triangle. The hypotenuse is 15 centimetres long. Calculate the length of the shortest side. So we've got 15. And then we've got an angle of 30. We've got an angle of 60 degrees. We've got an angle of 90. Okay, the shortest side is going to be opposite the 30 degrees. Okay. So it's opposite and we've got the hypotenuse. This is the opposite. So we're going to use sine ratios. And we want the shortest side, which is the opposite. So it's sine of 30 times 15. So the shortest side is 15 times sine 30 degrees. Now sine 30 degrees is one that you need to remember, and that's a half. So it's 15 times 0.5, 7.5 centimetres. So number 9, there's a total of 250 men, women and children on a train. The ratio of men to women is 4 to 5. The ratio of women to children is 10 to 7. How many men on the train? So we've got 4 to 5 is men to women. Okay. So the women there is 5. The women in this ratio is 10. So I'm going to make this 8 to 10. Because 4 to 5 is the same ratio as 8 to 10. And then women, because then we can fit the children in as well. You see, once it's at 10 there. So that's going to be 7. Because it's women to children is 7. How many men on the train? So the total parts is going to be 8 plus 10 plus 7, which is 25. 250 divided by 25 is 10. So that means we've got 80 men, 100 women, 70 children. Let's just check. Men to women, 4 to 5. Yes, there are 4 20s, 5 20s. Women to children, 10 to 7. 100 to 70 is 10 to 7. So it's 80 is the answer. ABCD is a quadrilateral. It is indeed. AD is AB. CD is CB. Prove that angle ADC is equal to angle ABC. Okay. I want to be efficient with this proof, so I'm actually going to look at the mark scheme because there's lots of ways of doing these. That's Jeannie. Yeah, be a second. Oops. It's question 21. It's question 10. Oh, huh. Yeah, so it's what we do is we split it into the two triangles here. Okay, AD equals AB, so that's sides are the same. CD is equals to BC, that's another side is the same, and AC is common to both. So if we look at, put your starting statement, consider triangles ACD and ABC is common to both. So it's a side again. Side, side, side means the triangles. I thought it was going to be more complicated than that for some reason. Are congruent. Okay, number 11. Amelia buys a new car. The expected future value of this car is given by V, 16,000 times 0.75 to the power of T. T is the age of the car in complete years. So when it's new, T is 0, so it's 16,000. Because anything to the power 0 is 1, so it's 16,000. Write down the annual percentage decrease in the expected value of the car. Well, see, after 1 year, it's going to be reduced by, its value is 75% of the original. And so that means it's reduced by 25%. Okay, show that the expected value of the car when 2 years old is £9,000. So 16,000 times 0.75 squared, 2 years old in there. So it's 1623 times 3/4 times 3/4 again. Okay. So this is 16,123 times 9 divided by 16. So we can divide this 16,000 by 16. So it's 1,000 times 9, which is equals to £9,000. Okay. Amelia sketches a graph to show the expected value of her car as it gets older. Decreases. Explain how you know that Amelia's graph is incorrect. It's not a straight line graph. I guess is what they want to hear. When it looks like this, this is an exponential graph, which is curved, not a straight line. So so the graph of 16,000 times 0.75 to the power T is not a straight line graph. Number C. Amelia assumes that her car will have no value at all after 20 years. Explain why her assumption is mathematically incorrect. Thinking of the best way to word this. I mean, these cars, they'll always have some value, even if it's just like the value of the scrap value. So 16,000 times 0.75 to the power 20 is what the value is going to be after 20 years. Well, 0.7, it's not equals to 0 because 0.75 to the power 20 is greater than 0. You're going to say the car will have some scrap value. Okay, so even though this will be a very small number, it's not going to be 0. So 16,000 times something that's not 0 is not going to be 0. Right, 5 divided by 6 as a recurring decimal. So you might know this off by heart, but if not, write it like this and that should give you a clue. It's 6 into 5 and you put the 5 and then a decimal point and some zeros. So there's 0 remainder 5, 6 is into 50, got 8 remainder 2. 6 is into 20, go 3 remainder 2, and look, there's your recurring part. Okay, so it's going to be 0.8 and it's the 3 that's recurring. Convert 0.126 recurring to a fraction, give your answer in its lowest terms. So our number is 0.126 recurring. Let's multiply it by 100. 100 times the number, 12.6 recurring. Okay. Then what do we do? What do we do now? So this is 100 times the number is 12, and that is 2/3. Okay, because 0.6 recurring is 2/3. So 100 times our number is 38/3. So our number, divide both sides by 100, is 38 divided by 300. And that will cancel down to 19 out of 150. Number 13. The graph shows information about the speed of a vehicle during the first 50 seconds of a journey. 0 to 50. At the start of the 50 seconds, the speed is k, there it is, meters per second. Distance travelled during the full 50 seconds is 1.35 kilometre. Work out the average speed, give your answer in meters per second. So the average speed is the total distance divided by the total time. Total distance is 1.35 kilometres, and that is 1,350 metres. 1,350 divided by 50, and that is going to be 27. You do 50s, it's 1,350, it's 2 at that point, remainder 35, 7. Work out the value of k. So what you've got to do for the value of k is the area is the distance travelled. So the area of this parallelogram, trapezium, is going to be 1,350. So the area, so the area of the square, rectangle, the area is, if we split it up here, 40k plus, because that's a rectangle, 40 times k. This is a right angled triangle, so it's half base, well that's 10, so half a base is 5, and height is k, so 5k, that is going to be there. So 40k plus 5k is 1,350 metres. So 45k, 1,350, so I've got to do 45s into 1,350, which is 330. So k is 30. Okay, and that's because the area of all these shapes have to add up. The area of these two shapes has has to add up to the total distance travelled from 350. So you work out the area, add its equivalent and do the division. Calculate the gradient of the graph in the final 10 seconds of the journey. Well, the gradient, what did I say K was? 30. So that's height is 30. So it drops 30 in 10 seconds. It's the change, the vertical change, divided by the horizontal change. So it's minus 30 divided by 10. So it's minus 3. What this gradient represents, this is the gradient on a speed time graph is the acceleration, because it's meters per second divided by seconds. So it's meters, because we're doing the vertical change divided by the horizontal change. So it's meters per second divided by second. It's meters per second per second. So it's an acceleration, which is actually in this case a deceleration. Acceleration, just move this to one side. Acceleration of minus 3 meters per second, or you could say it's a deceleration of 3 meters per second. Just checking my spelling of deceleration. Yep, got it spelled right. Just didn't look right. Okay. Right, 14. Adam has 10 sweets in a bag, 5 cherry, 4 lemon, 1 orange. Adam chooses a sweet and eats it, and then he takes another sweet and eats that. Adam says the probability that I choose 2 cherry sweets is 25 out of 100. He's incorrect. Explain his error. Okay, so you can either have a cherry or no cherry. That's 5 out of 10. So that's going to be 5 out of 10 for no cherries. And then, but then he's eaten the first. If he gets a cherry first time, he's only got 4 left. 4 out of 9. No cherry, he's still got 5 out of 9 there. If he doesn't get a cherry first time, he's got 5 out of 9 for a cherry there. And then if he doesn't get a cherry first, cherry, no cherry, cherry, no cherry, that's going to be 4 out of 9, that one there. That makes sense? So if he's on this branch, the C's gone down. They're always out of 9, but the number of cherries has dropped to 4, whereas not cherry has stayed as 5. If he hasn't got a cherry first time, he's still got 5 in the bag. Or if he doesn't get a cherry, it's gone down to 4 in the bag because he's eaten it. Case is incorrect. 2 cherry sweets. Probability of cherry and cherry is 5 out of 10 times 4 out of 9, which is 20 out of 90, which is 2 nights. Okay. Find the probability that they have different flavours. So I've either got cherry, lemon, or orange. Cherry, lemon, orange. Cherry, lemon, orange. Cherry, lemon, orange. 5 out of 10, 4 out of 10, 1 out of 10. And then eats that one, so that one goes down. These are always out of 9, these ones. Okay. Out of 9. So the lemon is still 4 there, and the orange is still 1. The cherry is 5 there. The lemon's gone down to 3, and the orange is still 1. This one, that one's still 5. That one's still 4. That one's no. Can't get orange and orange. Okay. So there's quite a lot of sums to do on here. So what we can actually use, we can say the probability of different flavours is 1 minus the probability that he gets 2 the same. Okay, because he either gets 2 the same or he gets 2 different. And there's fewer branches where we've got 2 the same. You say every branch and every from this seed there's the same, but then 2 different. The same, 2 different. The same, 2 different. Okay, so we can do 1 minus the probability is slightly fewer calculations. So probability of 2 cherry is going to be 20 over 90, 2/9. Lemon is 12 over 90. Let's put that back as 20 over 90, 12 over 90 there. Lemon, cherry, orange is nothing. Okay, so that's, you can't get orange because there's only one of them. So it's 90 over 90 minus 32 over 90. So it's 58 over 90, which cancels down to 27 over 45. Nope, 29 over 45. Okay. Yep. Quite late at night for me, this is. Nearly there. 15. ICRA carries out a survey of 200 families in the north of England on their weekly spending on food. And there's cumulative frequency diagram for the results there. The median. So to get the median, you've got 200 families, so you have to read off a family 100, which is to there, which reads off to there, which is £90. So that's the median. And the interquartile range, so this is the upper quarter, which is going to be 150. Zoom in a bit here. Oops, what's happening there? Right, so that one there, that's the upper quartile. It's going to be 100. And then you take away the lower quartile, which is this one here, which looks like 78. So it's £22. ICRA says 15% of these families spent over 200. Is she correct? So if we've got spent over 120. So let's see how many people spent over 120. Let's read off this way now. To me that looks like 182 people. It's just slightly above there, look. So 182 spent less than 120, because these people spend less than 120 here. Okay, but the ones who spent more are these ones here. They spent more. Okay, so we've got 18 out of 200 people. Okay, so that's 182. So we've got 18 in that category and 182 in that lot there. So 18 people. 18 out of 200 spent more than £120, which is 9%, because it's 9 out of 100. Okay. So she's not correct. In a survey of 200 families in the south of England, the median weekly amount spent on food was 84. Interquartile range was 20 8. Make comparisons. Okay, so we can say the median in the north was £6 higher. The median in the north is higher than the median in the south. So families in the north spent more on average than families in the south. And then the interquartile range, so that one's 22 and that one was 28. That's the interquartile range there. So that means that there's more variety. There is more variation in the spread of spending by families in the south, as 28 is greater than 22. Okay, number 16, write root 12 plus root 75 in the form k root 3. So the root 3, so 12 is 4 times 3. So root 12 is root 4 times root 3, which is 2 root 3. 75 is 25 times 3. So the square root of 75 is the square root of 25 times root 3, which is 5 root 3. So our answer is going to be 7 root 3. So 16 to the minus 3/4. So this is 1 over 16 to the 3/4. So it's 1 over the 4th root of 16 cubed. Okay, so the denominator, that's the root. And then the numerator of this fraction is, you raise that answer to that power there. Okay, and the 4th root of 16 is 2. So it's 1 over 2 cubed. So the answer is 1/8, because 2 cubed is 8. Solve the inequality x squared minus 5x minus 6 is less than or equals to 0. I'm just going to see how they do that in here. Yeah, I haven't really got a method, so that's fine. X squared minus 5x minus 6 is less than or equals to 0. So this factorises as x minus 6, x plus 1 less than or equals to 0. Minus 6x plus 1x is minus 5x, and that's minus 6. So when we sketch the graph, it's cutting at 6 and at minus 1. So it's a quadratic that looks like this. So x squared minus 5x minus 6 equals 0. And x is plus 6. So that 6 minus 6 is 0. So it's going to make this 0 overall. Or x is minus 1. Okay. So the inequality is less than 0 here when x's lie between minus 1 is less than x is less than 6. Oh, it's less than or equals to. It's less than or equals to. Prove that the difference between two consecutive square numbers is always odd. So consecutive square numbers are n squared and then n plus 1 squared. Okay, so the difference is n plus 1 squared minus n squared. N plus 1 squared is n plus 1 times n plus 1, n squared plus n plus 1. So this is n squared plus 2n plus 1 minus n squared. N squared cancels. 2n plus 1. 2n plus 1 is odd, as 2n is even. Solve the simultaneous equations, algebraically, end of question paper. So we've got y is 2x squared minus 7x plus 4, and y is 4x minus 1. So if these are both y's, then therefore that is equals to that. It's got 2x squared minus 7x plus 4 equals 4x minus 1. So 2x squared, subtract 4x from each side, minus 11x. And then 4 plus 1 is 5. Okay, so when we've got this here, the way that I've always done it, we need two numbers that multiply to make 10. So the numbers need to multiply to make 10. That's plus 10. And the 10 has come from the 2 times the 5. And they've got to add to make minus 11. So these numbers are minus 1 and minus 10. So what we do then is we separate out the minus 11 in the middle as minus 11x as minus 1x, minus 10x plus 5 is 0. So that first one is 2x minus 1. And then this is plus, minus actually. Go for a minus there. Minus 5 times 2x minus 1. Okay, because so we separate it out. We separate this out these ways: minus 1x minus 10x, and then you factorise these first two, and then you factorise these second two. So they factorise with an x, and it leaves 2x minus 1. These two factorise with a minus 5, so it's plus 2x minus 1. For x minus 5 times 2x minus 1 is 0. So either x is 5 or x is a half. It's got x equals 5, x equals a half. Y is 4x minus 1. So if x is 5, y is 4 times 5 minus 1, which is 19. If x is a half, y is 4 times a half minus 1, which is 1. That's the end of that paper.